Okay, last video. Final page of the study guide, problem number 22. We're told in the stem of the question the graph of the function f is given above and it consists of 3 line segments. For part A, we're told that g is the integral from -4 to x of f of t dt. So not only is this the graph of f, we also know it's the graph of g prime. All right, that's going to be important. For each of g of -1, g prime of -1, and g double prime of -1, find the value or state that it does not exist. So g of -1 is the integral from -4 to -1 of f of t dt. So we're going to start at -4, and we're going to go to -1, and we want the area of that region. It's a trapezoid, so 1/2. The height, 1, 2, 3 units, times the sum of the bases. This one is 3 units, right? Because the y-coordinate is a -3, so we have a 3-unit base, and then we have a 2-unit base. Now what's important to remember here, this area, this region, is below the x-axis. So we need the whole thing to be negative. Alright, so 3 plus 2 is 5, 5 times 3 is 15, so we have -15/2. G prime of -1, very easy to get. This is the graph of G prime. What's the coordinate when x is -1? The y-coordinate is -2. G double prime of -1, this is the slope of G prime. Here's the graph of G prime. What's up with the slope right here at this point when x is -1? Exactly, it's a sharp point. Therefore, G double prime does not exist. Just says we have to state that it does not exist. It doesn't say that we have to say why. But G double prime of -1 does not exist. Part B. For the function g defined in part A, find the x-coordinate of each point of inflection on the open interval from -4 to 3 and explain your reasoning. Okay, so a point of inflection, we're going to do the reasoning first. Point of inflection occurs when, because g prime, which we know is the same thing as f, changes. All right, point of inflections when the derivative changes from increasing to decreasing or decreasing to increasing. All right, so let's go look at our graph of g prime. The graph is increasing, and then it changes to decreasing right there. What's the x-coordinate? Because that's all we're asked for. The x-coordinate is 1. So at x equals 1. And again, it's because that's the only spot where the derivative of g changes from increasing to decreasing. Okay. Next up, part C. Let h be this function. That's another accumulation function of f. Find all the values of x in the closed interval in which h of x is equal to 0. Okay. Well, right away we got one answer, because we know that if the bounds are the same, the integral will be equal to 0. So h of 3 will be the integral from 3 to 3 of f of t dt. That's guaranteed to be 0. So x equals 3. That's one value. It doesn't actually say that we have to show y, but I'm putting that down just so you can see. All right, so where is 3? Let's go back up here. Here's 3. All right, so we can only move to the left. When we move to the left, we get to this. I'm going to change colors here, just because I already got some red on there. When we move to the left, we create this triangle right here. Now, if we keep moving to the left, eventually we're going to get this far as well. Can you see how those two blue triangles are going to wipe each other out? They're the same size, but one's below the x-axis and the other one's above. So whatever area we add or subtract immediately gets wiped out by addition or subtraction from right here. Right? So because we started at 3, and when we were at 3, h of x was equal to 0, as we move to the left and get to when x is 1, that's another spot where h will be equal to 0. Now, when the graph was on the screen, did you see a third spot? If you did, good. Let's keep moving. Let's move. Now we accumulate that gray area. But then we also accumulate this gray area. And just as the blue areas wipe each other out, so do the gray areas. So the last time that h is equal to 0 is right here at -1. Those are the three values when the function h is equal to 0. That's a hard one. If you got that, good job. The last one's easy. For the function h defined in part C, find all intervals on which h is decreasing. All right? H is decreasing when h prime is negative. What's h prime? Well, here's h. So h prime is just f. We replace the t with the x. So this graph right here, not only is it the graph of f, it's also the graph of g prime, and it's also the graph of h prime. We just need to know when this graph is negative. It's negative here and here. What are those intervals? From -4 to 0, and then from 2 to 3. -4 to 0, and 2 to 3.